Hey, can you hear me?
Yes, I can hear you, sir.
Can you see the screen?
I see your picture only.
See my picture, huh? Wait, I see first. I cannot. Can you see my face or not?
No,
No. Let me see. What
I know
happened?
it.
Share screen. Let's see this one. Can you see the screen?
I can see the screen.
Can you see the slides? I mean,
Yes, I can see it.
can.
Yeah, it's the projectile motion one, right, sir?
Okay, okay.
So
Then
what chapter is this right now?
this is chapter three.
Chapter 3. Okay.
This is chapter three. This one. Chapter 3, the in the syllabus it is, where is it? In your syllabus it is this one. This one. Vector
Okay.
and two-dimensional motion. The last one, projectile motion. So actually this chapter there's also relative velocity, but then it is not
Okay.
inside your syllabus. So there's
Okay.
not going to do relative velocity. Okay, right. You can see the screen, right?
Mm-hmm.
Okay. So, see whether it's recording or not. Let me check. Yeah, it's recording.
It's recording. It's
Okay,
recording.
right. So, so we come to this problem. Did I go through this problem with you or no?
Exercise 3.2, we haven't started here yet.
Not yet. Then this one, a projectile move in the parabolic. This one we have finished. This one we have
Mm.
finished. So we come to this problem. Right. Can you read this one? The problem.
An Alaskan rescue plane drops a package of emergency rations to stranded hikers, as shown in figure 3.10. The plane is traveling horizontally at 40 meters per second at a height of 1 times 10 to the power 2 meter above the ground. Neglect air resistance. Where does the package strike ground relative to the point at which it was released? What are the horizontal and vertical components of the velocity of the package just before it hits the ground? And C, what is the angle of the impact?
Okay. Now, for this problem, it is our starting point is this one. The zero level is at the aeroplane here.
Okay,
So, when you drop the parcel, is it drop package? Sorry, when you drop the
drop package,
package,
yes.
the horizontal component of the velocity of the package is the same as the aeroplane because the package is inside the aeroplane. So when you release from the aeroplane, you possess the velocity of the aeroplane. That is the horizontal motion,
Okay,
40 meter per second. Then because the package is not thrown down, it is just dropped down. So the vertical component of the velocity is 0. So we have here
okay,
horizontal 40, vertical 0. Then
okay,
the position at this point is 0, right? We count from here. So when it drops to the ground, of course it will not
okay,
drop vertically downward. It will
okay,
move like a parabola like that. So when it
okay,
reaches the
okay,
ground, it is negative 100. The displacement, the vertical displacement is negative 100.
I see,
And
okay,
the horizontal one, we don't know. Unless we know what is the time taken, then we multiply with the horizontal component, then we will know
mm-hmm.
what is the distance, the horizontal distance traveled.
Sense,
Okay,
okay,
so A, where does the package strike the ground relative to the point at which it was released? So that means we consider this as 0, 0, right? We consider this as 0, 0. So the things that are given, the initial velocity is the initial horizontal component is 40, vertical component 0, acceleration
Mm-hmm.
is negative g. When it
Okay.
strikes the ground, the delta y is negative 100. So what is the delta x? Delta x is the horizontal distance. Delta y is the vertical distance. Okay, right.
Distance.
So we have here one, two, three, four equations. Which one of these we are going to use? Oh, you have to bear in mind that our distance, velocity, and time. Okay, of course the time is shared. The time is common between the vertical component and horizontal component. You
Mm-hmm.
use the same time. But when it comes to velocity and displacement, you have to consider them separately. The vertical velocity and the vertical distance, the horizontal velocity and the horizontal distance. So in
Okay.
order to find the horizontal distance, the horizontal distance is the velocity multiplied by time. The horizontal
Yes.
velocity multiplied by the time. But we don't know the time, right? So we don't know the time,
Mm-hmm.
even though we know the horizontal component of the velocity is 40, we don't know the time here, this one, okay? So we
Yep.
have to find the time first. So from where are we going to find the time? We are going to find the time not from the horizontal component, but from the vertical component, from the vertical component.
Okay.
Okay, so the vertical component, the relationship between the displacement and time, we take this equation number 2. Okay, we
Okay.
take equation number 2 and we substitute in the displacement, the velocity, the acceleration, which is half g, half times g, sorry, all this we substitute in using the horizontal component. Okay, right.
Okay.
So the horizontal component, the displacement when you reach the ground is negative 100. Let me see, where is it? Yeah, this one. Okay. So when you reach the ground, it is negative 100. This one. The delta y, you substitute with negative 100. Then, because the vertical component, because it is dropped from the plane, it is not thrown down. So the vertical component of the velocity is 0. The
Okay.
time, the time is what we want to find, right? Then
Yes.
the half, okay, is still half. Acceleration due to gravity is negative 9.8. And this time is what we want to find. The time is the one that is common for both components, and this will this is the relation between them. We are going to use this.
Mm-hmm.
Okay, so solving this equation, it is not quadratic actually, because this one is 0, no?
Mm-hmm.
Because this one is 0, so it is just square root, right? Square root of 100, 200 divided by 9.8, so it's 4.52. But the time is not what we want to find. We want to find what is the distance here, right? What is this
Right.
distance here? So in order to find the horizontal distance, we refer to the horizontal component of the velocity multiplied with
Okay.
time. The horizontal component is not affected by gravity, so the distance is velocity times time, that's all. Right? You don't have to use this type of equation. You just use velocity times time, you'll find the horizontal distance. So 40 is the
Yes.
initial velocity, time is 4.52 we have found earlier. So total 181 meter. Okay. So far, can you follow?
So far so good. Yes, can follow.
Okay. So we just use the vertical component to find the time. How much
Mm-hmm.
time is taken to reach the ground using the
Yes.
acceleration due to gravity. So using this time, we substitute into the horizontal component to find how much is the horizontal distance traveled. Okay. So
Okay.
the second part, what are the horizontal and vertical component of the velocity of the package just before it hits the ground? Okay, so this thing fly down. This is the trajectory. One thing that we know is the horizontal component will not change because we neglect the air resistance. So the horizontal component of the velocity is this one, 40 meter per second. What is the vertical component of the velocity? The vertical component of the velocity, we have to consider it separately, right? Separately. So only the vertical component, we try to use this formula here. Okay, the vertical component. For the horizontal component, velocity is constant. The displacement is velocity times time. That's all. So for the vertical component, we have to use these four equations. So to find the final velocity, you can either use this one, which has final velocity, or this one, which has the final velocity. So which one is simpler? Of course, the first one is simpler, right? The first one involves the initial velocity, acceleration, and time. So we're going to apply this equation, this one here. Okay, this equation here, right? We're going to apply the first equation, and the final velocity equals to the initial velocity. This is the initial velocity. This is the initial velocity. Because the package is dropped, so the initial velocity is 0. The acceleration is the acceleration due to gravity, which is negative g. And the time is the time for it to drop to the ground. And we have found earlier 4.52. So substitute in 4.52 and you get the velocity as negative 44.3. Right. So we have found the horizontal component and also the vertical component of the velocity. Okay. Next, what is the angle of impact? Angle of impact means at this point here, what is the horizontal component of the velocity and what is the vertical component of the velocity, right? Now, when we combine the two components, the actual velocity will be something like this. Will be something like this. And the angle of impact is actually this angle here. This angle here. Okay. The angle between the horizontal and the velocity. Now, what I am drawing here is actually something like this, right? Where is it? This one is something like this, right? Something like this. Where is it? Could be this one, right? This thing here, right? Now, we have the vertical component and the horizontal component, right? And if you merge these two components together, you will get back the actual velocity and the actual direction in which the package is moving, right? If you merge these two together, you will get back as I've said earlier, the two components, they are equivalent to this actual velocity. But when you resolve the actual velocity into the two components, then you only see the two components, right? Actually, they are moving like this, the red arrow like this. Okay. So coming back to our problem here, what we have been doing is we try to capture what is the horizontal velocity and what is the vertical velocity, the component. But now we want to find the actual velocity is this one. We want to find what is the angle of this actual velocity with the horizontal. Okay, so this one is this is the actual velocity, and this is the angle with the horizontal. So in order to find the angle, we use the vertical component divided by the horizontal component. That will be the tangent of this angle of impact. The actually the package is traveling like this one, right? The how to say, it's actually traveling like this, not in the form of component. It's actually traveling like this, the center one. So we want to find what is this angle of the actual velocity with the horizontal. So we use the vertical component of the velocity divided by the horizontal component, and that will be the tangent of the angle of impact. That is the tangent of this angle. So using your calculator, then you find arctangent of this number. So the arctangent of this number is negative 48 degrees. Negative because it is pointing downwards. It is in the fourth quadrant. That's why if you rotate clockwise, then it is anti-clockwise, then it's positive. If from the horizontal you go downwards, clockwise, the angle is negative. Okay, so far any question about this projectile? Where is it now? This one, right? So in the textbook, you are we are doing this projectile, right? The projectile, then after this projectile, it is relative velocity. Now this one is not in your syllabus, right? The relative velocity. Coming back to here, right? Any questions so far? Hello, are you with me?